Hi students, methods of preparation of aldehydes and ketones, and today we are preparing them, that is aldehydes and ketones. We will prepare from alkynes and then we see what else we take. So I want to prepare aldehydes and ketones, and the name of the method is hydration of alkynes. The name of the method is hydration of alkynes. Hydration of alkynes. When an alkyne is treated with 40% H2SO4 and 1% HgSO4, then a molecule of water gets added to the alkyne and we get corresponding aldehyde ketone. Quick tautomerism is involved in the process. I'm taking an example directly. This is again just a revision of what we have already done in 11th standard in the topic alkynes in the state board and the topic hydrocarbons in the NCERT board. Now this reacts with a molecule of water, and the process, the reaction takes place in presence of dilute H2SO4, that is 40% H2SO4 and 1% mercuric sulfate, AgSO4, and say this goes here, so this goes here. We get H, C, and H here. The triple bond becomes the double bond, and a OH and a H. This is vinyl alcohol. This is vinyl alcohol, also called ethanol. And this is ethyne. Or we also call it acetylene. So that's ethyne, and we also call it acetylene. So this is a molecule of acetylene, and now immediately this, which is unstable, will tautomerism. It will tautomerize to acetaldehyde. So that's acet, aldehyde, we call it ethanol. So that's how we can convert alkynes. That's how we can convert the alkynes to aldehydes. Now one question for you. I'm not giving the answer directly, and the question is, student, what I want to know is, just now you see, I prepared acetaldehyde. What I want to know is, which other aldehyde can be prepared by this method? I'm just looking into the chat box. Yeah. Oh. Someone gave the answer. No other aldehyde, and that's beautiful. You remember 11th standard syllabus too. That's really great. You know, we can't prepare any other aldehyde by this method because the moment we increase the number of carbon in the alkyne, say we consider the example A and I take B, I'm just increasing one carbon, okay? So I'm taking CH3, C, triple bond CH. Now children, when we take this, we all know that the negative part of the reagent, I hope you remember, the negative part of the reagent will get attached to carbon having less number of hydrogens attack. And when this happens, we get CH3, COH, CH2. So how we can get an aldehyde? Because always now any alkyne you take, the OH will come in the center, and whenever oxygen is in the center, we can't get aldehyde because aldehydes are primary, and the position of the functional group of aldehyde is always position 1. So this is 40% H2SO4 and 1% AgSO4. Now this back here, it tautomerism, and we get a molecule of acetone. So this is, we just write the name, this is acetone dimethyl ketone, also called propanone. So you go on writing now, you cannot get an aldehyde. You will get a ketone only. And hence, by hydration of alkyne, we can prepare only one aldehyde, and that is acetaldehyde. Rest all the molecules we'll be getting is ketones. Okay. Now we move ahead. And now we just complete the methods of preparation for the aliphatic aldehydes. Aromatic we will see in the next video. The next reaction which I am teaching is stiffen. The stiffen reduction, which we carry out using an alkyl cyanide and stannous chloride and HCl. So what happens is, we take stannous chloride, we treat it with HCl. As a result, we get stannic chloride and nascent H is generated. So this nascent H helps in the reduction when we move ahead. Now we take a cyanide, say acetonitrile molecule, acetonitrile, also called methyl cyanide, also called methyl nitrile, yeah, also called ethane nitrile. I'm writing the IUPAC name, also called ethane nitrile. Okay, now I want to reduce this, so we use the nascent hydrogen, 2 atoms of nascent hydrogen, and HCl gets added along, and this happens in presence of dry ether. So we get CH3CH double bond NH. Can you guess? 2H are there, NH, HCl as it is. Okay, so that is what we are getting as acetaldehyde hydrochloride. This is acetaldehyde hydrochloride. Now next, this acetaldehyde hydrochloride on boiling with water gives acetaldehyde. Here it breaks, cat, and we get 2H है, 2 ये, O तो इधर आ जाएगा, इधर O आ जाएगा, इधर O आ जाएगा ये, और ये मिला NH4Cl. So that's how we got ethanol, and this is stiffen reduction. This is stiffen reduction. Now this method will always give us aldehydes only. We cannot get ketone because cyanide खुद एक primary group है, और primary group से हमेशा प्राइमरी कंपाउंड ही मिलेगा, तो एल्डिहाइड ही मिलेगा. हाँ, अगर ये साइनाइड में मैंने ग्रिग्नाट डाला होता जो हमने पहले किया, तो फिर कीटोन मिलता और एल्डिहाइड कभी नहीं मिलता, क्योंकि एक इसका आर, साइनाइड का आर, और एक ग्रिग्नाट का आर, तो कीटोन मिलता. ओके, वी कैन टेक वन aromatic example also. Let us take one aromatic also. Only I'm writing. Just a minute. Just a minute. So this is A. We're going to B. Okay, I'm writing with this color only. Take stannous chloride. We do 2 molecules of HCl. It's giving me stannic chloride and 2 atoms of nascent H. Now we take benzonitrile and we treat benzonitrile with 2 atoms of nascent H and a molecule of HCl. Don't forget to write dry ether above the arrow written. So we get benzaldimine hydrochloride like this. Correct? This is benzaldimine hydrochloride. Don't forget to name each and everything. So I am naming this also. This is benzonitrile. And now we have benzaldimine. Imine is CHNH group, hydrochloride with boiling water, samosa. Here also heat. We get benzaldehyde and NH4Cl. That's the way. So this is benzaldehyde benzenyl. Also called benzene carbaldehyde, also called benzene carbaldehyde. So that completes stiffen reduction. I hope it's clear to everybody. And now not a part of stiffen reduction, but something more is there. Something more is there, and what's that something more? Children, that something more is in like stiffen reduction. Of course we can use, but then there's one more way to do the conversion, and that is what had a heading to give. That's what I'm thinking. Okay, let's give the heading. It's a different. कुछ अलग है, पर ये भी है. Okay. So now what we are doing is reduction of alkyl or aryl cyanide using DIBAL. What is DIBAL? DIBAL is diisobutyl aluminium hydride. So using DIBAL, what is DIBAL? डाइआइसोब्यूटाइल एल्यूमिनियम हाइड्राइड. डाइआइसोब्यूटाइल, आइसोब्यूटाइल का पहले थोड़ा बना देते हैं. CH3 twice CH, ये आइसोप्रोपाइल हो गया, ये आइसोब्यूटाइल हो गया, इसका डाइआइसोब्यूटाइल एल्यूमिनियम हाइड्राइड. This is the structure of DIBAL. I mean the formula. Then you can just expand and write the structure. Now this is a reagent for selective reduction. This reagent does selective reduction. Selective reduction. DIBAL is a selective reducing agent. What's so great about it? What's so selective about it? It does not, listen carefully, it does not reduce ethylenic double bond. Ethylenic carbon-carbon does not reduce carbon-carbon double bond, does not reduce olefinic linkage. तो क्या हो गया? नहीं reduce किया तो. Hence can be used to convert. Can be used to convert unsaturated alkyl cyanides, unsaturated cyanides to unsaturated aldehydes. ये इसका सबसे बड़ा फायदा है. Okay, so it can do that. Unsaturated alkyl cyanides to aldehydes. So for example, कौन सा मॉलिक्यूल लें, क्या लें? चलो टेक्स्ट बुक का ही लेते हैं. पेंट 3 in 1 nitrile, ये लेते हैं. ठीक है. So पेंट 1 2 3 4 5, नाइट्राइल 1 पे 1 2 3 3 पे डबल बॉन्ड और 3 2 एक हो गया. नाउ विद DIBAL एंड वाटर, खाली ये जो पार्ट है ना इसको इफेक्ट होगा. CH3 CH2 CH, डबल बॉन्ड को कुछ नहीं हुआ. ओए डबल बॉन्ड को कुछ नहीं हुआ. CH CHO, so pent 3 in al, pent 3 in al, we got the aldehyde. Okay, pent 3 in al. Obviously खाली aldehyde ही बन सकते हैं, कीटोन तो नहीं बन सकते, खाली aldehyde बन सकते हैं. अच्छा, it's different. Again one more it's different is coming. अभी क्या हेडिंग दे? Do you know? No, we don't know. Do you know? No, we don't know. Okay, what is this? Do you know? Esters are partially reduced by DIBAL to aldehyde. और बिल्कुल वैसा ही है. Esters are partially reduced. Partially क्यों बोल रहे हैं? क्योंकि कंप्लीट रिडक्शन पे एस्टर अल्कोहल दे सकता है. सो ये क्या खास है? एस्टर्स आर partially reduced to aldehydes using DIBAL. Right? So esters are partially reduced to aldehydes using DIBAL. And you know what is DIBAL? Diisobutyl aluminium hydride और structure भी है यहाँ पे. Okay? अब इसका एक रिएक्शन लिखते हैं बच्चों. एक रिएक्शन लिखते हैं इसका. बढ़िया सा बड़ा सा कुछ एग्जाम्पल लिखते हैं. चलो इसका रिएक्शन लिख देते हैं. मिथाइल डोडेकेनोएट. ठीक है, क्या ले रहे हैं हम? मिथाइल डोडेकेनोएट. पहले तो O8 का स्ट्रक्चर ऐसा होता है CO. अब जो पहला अल्फाबेट है मिथाइल दैट इज R अटैच टू O. और दो डेक यानी 12 कार्बन, तो CH3 एक यहाँ ले लिया, CH2. अब देखो एक और एक ये 2, मतलब यहाँ है 10. ठीक है, 12 हो गए, दो डेक यानी 12. अब डाल दो रिएजेंट DIBAL, और बाद में ऑब्वियसली DIBAL ईथर में काम करता है, और बाद में पानी डाल दो हाइड्रोलिसिस के लिए, तोड़ने के लिए. अब ये इधर कट हो जाएगा. एस्टर लिंकेज, दिस लिंकेज इज कॉल्ड एस्टर लिंकेज, आल्सो कॉल्ड असाइल ऑक्सी लिंकेज. ध्यान से देखो किधर पॉइंट आउट कर रही हूँ. दिस एस्टर इज असाइल ऑक्सी लिंकेज, आल्सो कॉल्ड द एस्टर लिंकेज. अब एस्टर हमेशा एस्टर लिंकेज पे टूटेगा. ये 10 और ये COH, तो ये बन गया डोडेकेनल. ओके, तो इस तरह से सारे मेथड्स ऑफ प्रिपरेशन हो गए एल्डिहाइड कीटोन्स के. अब नेक्स्ट वीडियो में कार्बोक्सिलिक एसिड्स के भी प्रिपरेशन करेंगे, लेकिन और साथ में हम एरोमेटिक एल्डिहाइड के प्रिपरेशन भी करेंगे. ओके, बाय बाय, सी यू. लव एंड ब्लेसिंग्स टू ऑल ऑफ यू.